In this video, I'm going to be finding areas under both the standard normal curve and areas under a normal curve with mean 615 and standard deviation 12. In the next video, I'll be doing the reverse. Given an area, find either the z-score or data value x that corresponds to that area. For this first example, we're asked to find two probabilities using the standard normal curve, and so it explicitly says use the standard normal curve. However, if it doesn't say and you're ever given the variable z, you should automatically know that you're working with the standard normal distribution and that your mean is 0 and your standard deviation is 1. So if we look at this first example, the probability that z is less than 1.4, I've already set this up in the applet, so you can see here that I have the mean set to 0 and the standard deviation set to 1. And the yellow region is the region from the smallest value of this standard normal curve, so -4, to positive 1.4. And so if you notice, I'm looking at the area under the curve to the left of positive 1.4. So in words, this is the area under the standard normal curve to the left of z equals positive 1.4. And this area is just given by 0.9192. To solve this using your calculator, you're going to find the normal CDF function, which is going to be in the distribution menu. And it's expecting 4 values. The first value that it's expecting is the minimum value on the curve that you're looking at. So either the minimum z value or the minimum x value. The next thing it wants is the maximum value you're looking at. And then it wants the mean of the distribution and the standard deviation of the distribution. So for our example here, we're going to have, and I'm going to abbreviate normal CDF as NCDF to save time. But so my minimum value, if you look at the applet, you can see that it's -4. However, personally, so that I don't have to think about it when I'm doing different distributions with different means and different standard deviations, I will always use -100,000. And that is guaranteed to give me every value less than positive 1.4. and most likely less than every value for any distribution I'm going to be looking at. And then the next value that I'm going to put in is the maximum value that I want to look at. And when you're doing probabilities to the left of a value, right, so with a less than sign, your maximum value is always just going to be the value that's given. And so here, my maximum value is 1.4, and if you compare that to the applet, you can see that the maximum value for that yellow region is positive 1.4. And then of course the mean is 0 and the standard deviation is 1, and when you put this into your calculator, you get the exact same value of 0.9192. Looking at part B of this example, we can see that our sign, our inequality, has flipped. And so rather than having less than, I'm looking for the probability that a z-score is greater than -2.1. And so in words, this translates to area under the standard normal curve to the right of z equals -2.1. And so if you look at the applet over here, I have that set up already. And so we can see that the area is 0.9821. And so that's the probability that I'm going to get a z-score greater than -2.1 for any distribution, right? If I were to standardize it back down to the standard normal curve. So let me show you how to put this into your calculator. You're still going to use the normal CDF function, and you're still going to be giving it the 4 values, the minimum, the maximum, the mean, and the standard deviation. However, your minimum value here, if you look at the applet and the yellow region, you can see that the smallest z-score for my yellow region is the -2.1. So that's my minimum value here. And you can see the maximum on the graph is 4, but again, I'm going to use positive 100,000. That way, if I'm not using the applet, I don't have to think about what the maximum value is going to be, right? 100,000 is a safe bet. And then I'm going to put in my mean and my standard deviation again. And when you do this, you do get the same area. In the second example, we're going to be moving away from the standard normal distribution, and instead we're going to be looking at the normal distribution with mean 615 and standard deviation 12. And we're going to find each of the following probabilities. I'm going to do it without converting these x values to z-scores. However, that is another way that you could solve these. Convert all of these x values to z-scores and solve it the way we solved example 1 up above. But let me show you how to do it when you keep them as x values. So if you look at part A, it's asking us to find the probability that x, or an x value selected at random from this distribution, is less than 612. If I were to translate this into words, again, this is saying find the area under this normal curve to the left of 612. So the key word there is left. So try and keep this association with you throughout statistics. It's going to come up again, primarily when you're doing hypothesis testing. Whenever you have a less than sign, it's talking about to the left of a data value, or when you get to hypothesis testing, it'll be called a left-tailed test. And so for now, if I look at the applet, so I've already got the applet set up with the mean of 615, standard deviation 12, and you can see that I have my yellow region, but if you look at this first dot up here, this 612.086, this is as close as I can get it to being exactly 612. And so my probability here is not going to be perfect. So what I'm going to do is I'm going to say that this is approximately equal to 0.4040. If you were to enter this into your calculator, you can still use the normal CDF function. And again, because you have that less than sign, you're finding areas to the left. And so I'm going to put in negative 100,000. The reason why I normally use negative 100,000 is because if I didn't have this applet in front of me, I would not know off the top of my head that 567 is the smallest value on the curve. And so that negative 100,000 just means that I don't have to do any of those calculations and it's always taken care of. So my minimum value here, negative 100,000, and when you're entering that into your calculator, make sure not to put any commas, because the commas, remember, are what separate the four numbers that you're entering. So I'm going to put in negative 100,000, and then the maximum value here is 612. And then now I'm going to put in the mean and standard deviation associated with this curve, which is the 615 and this 12. So 615, 12. When you put that all into your calculator, you get 0.4013. And so you can see that the two probabilities are close. And so when you're doing these probabilities and you're using the applet and you're not getting exact probabilities, always use the approximate sign. And then you can say, I should use the approximate sign here, it's approximately equal to 0.4, which is true. If I were to round this, I would get 0.4. In part B, we're looking for the probability that a randomly selected x value is greater than 590. And so in words, this would be the area under the curve to the right of 590. And again, this is going to be a common thing. Whenever you have greater than, you're going to be associating it with the word right in some form. So when we look at this applet, we can see that the area to the right of 590 is approximately equal to 0.9815. And again, it's not going to be exactly that because I can't get it, this value, this green value up here, to be exactly 590. That's as close as I can get. When you use the normal CDF function, so n CDF, my minimum value here is now 590. My maximum value, I'm going to use 100,000 again, just so I don't have to pay attention to what the actual maximum value on this curve is. And then my mean, which is 615, and my standard deviation, which is 12. When you put this into your calculator, you get an exact value of 0.9814. And so these two values are actually very close, and so this approximation is a much better approximation than the one we had above in part A. For part C, we're going to be finding the probability that a randomly selected x value from this distribution is between 580 and 619. And so I have that ready to go in the applet. And if you look, I'm a little over 580 and I'm a little under 619. So hopefully it kind of evens out to the exact probability, but we'll see. And so here we can see, I'm still going to put approximately because I don't have those exact values. And so this area, or this probability, is approximately equal to 0.6270. When you put this one into your calculator using the normal CDF function, you don't have to worry about negative 100,000 or positive 100,000 because you have both your minimum value and your maximum value given. And so here my minimum value is the smallest number, the 580. My maximum is the largest, so 619. And then again, my mean, 615, and standard deviation of 12. When you put this into your calculator, you get an exact value of 0.2688. Actually, that's not exact because I rounded it to 4 decimal places. It gives you a lot more than that. But this is pretty close, right? It's not as good of an approximation as part B is, but it's a pretty decent approximation.